Hi guys, welcome back to the channel. Today we're going to solve another coding interview question. Today's question is partitioning a linked list. So this question is from Cracking the Coding Interview. I've been solving a few questions from Cracking the Coding Interview for a while now, and I have all of them in my repository, my local copy. Let me know if you want me to solve more questions from Cracking the Coding Interview, and then if you want me to upload them to GitHub. So I don't want to upload questions to GitHub unless there's an explanation for it on this channel. So I don't know if that makes sense or not, but if you're a little ahead in the coding interview prep process, you might just look at the questions and then you know how to solve it. So let me know if you want me to upload solutions to questions on GitHub that I haven't made a video about on this channel. So this question gives you a linked list and a pivot value. This is the pivot value and this is the linked list. Pivot value and input linked list. And then you should partition this linked list around the pivot value. So all the elements less than the pivot value come before the pivot value, and then all the elements greater than the pivot value or equal to the pivot value come after. So to solve this question, we're going to create two linked lists. One list is going to hold the nodes less than our pivot value, and then the next linked list, the other linked list, is going to hold nodes greater than our pivot value. And after iterating through the list, building those two linked lists, and then we merge those two linked lists together. So I'm going to write solution. We're going to have two linked lists. One for before. I'm going to put it in yellow. So I'm going to call it before, but what it does is it just stores nodes less than the pivot value. And then another linked list for after, and this dude just stores nodes greater or equal to our pivot value. So remember, we have one caveat in the question, and the caveat is if the pivot value, which is this guy right here, 5, it can be anything. If the pivot value is contained within the linked list, we have pivot 5. Let's say if it's contained within the linked list, which it is. Sometimes it cannot be, but in this case it is. If it is contained within the linked list, it should be among the nodes that are after. It should be in the after nodes, among the nodes that are greater. So the pivot value shouldn't be, let's say, it shouldn't be between the before nodes and then the after nodes, right? It shouldn't be here. It should be among the nodes that are after. So that's what I got from this question. So whenever we get to a node that's either equal to or greater than the pivot value, we put it in the after list. So that's how you solve that caveat. So let's go through an entire example. Iterating through this linked list, we get to 3. Is 3 less than 5? Yes, it is. So we add it to the before list, which contains nodes less than the pivot value. And then we get to 5. Is it less than the pivot value? No, it's not. It's equal to the pivot value, so we add it to the after list. So we add 5, and then we get to 8. It's greater, so we add 8, and then we get to 5. It's greater, we add 5. Then we get to 10. It's greater, we add 10, and then we get to 2. 2 is less, so we add it to the before list, and then we get to 1 less. We add it to the before list, and now we're done iterating through the array, so now we have to merge these two lists together. So merging the two lists is going to be really easy because we're going to keep track of the head and tail of both lists. So all we have to do is to connect the tail of the before list to the head of the after list. And that's it. We just return it. So that's how we solve this question. I'm going to write the code. I'm too lazy to draw up test cases and all of that, so I'm just going to do the code. So what's the time and space complexity of this algorithm? Well, for time complexity, we're going through all the nodes in the linked list, so it's clear that that is O of n time. And then for space complexity, we're storing two lists that are going to contain at most half the number of nodes each. So combine those together, that's n nodes. So space complexity is O of n, time complexity is O of n. So t is equal to O of n. And then space is equal to O of n. All right, so let's dive into the code. I usually go to this website called jdoodle.com to write Java code online. So let's do that. Alrighty, so we create a public list node, partition, and then it's going to take in a list node. Let's just call it node. it's the input list, and then it's also going to take in an integer, p for pivot, and then from here we're going to partition the lists. All right, so we're going to keep track of 4 things: head and tail of the before list and then the after list. So let's say list node before head is equal to null, and then list node after head is equal to null, and then list node. So now that we have this, we can iterate through our linked list with a while loop. So while node is not equal to null, we're going to copy a temporary variable for the next node is equal to node.next. And then you'd see why we're doing this in a bit. And then after this, we're going to cut off all the connection to we're going to connect the connection for this node to the other nodes, right? So since we're going to use this node later, we want to cut off its connection to other nodes. So remember, in a linked list, all the nodes are connected. So if you just set node.next to one node, and then all the other nodes are in the background, and they're technically indirectly connected, and then you don't want that, right? Since we're going to use this node. I will explain when we get to the part where this comes in handy. So let's just set next node.next to null. And then now we can check if node.value is less than p. If it's less than p, we want to add it to the before list, and then if it's greater than p, we want to add it to the after list. So I'm just going to say insert in the before in the before list. All right, I don't know how to spell insert. So how do we insert in the before list? So first of all, you have to check. You don't just insert it into the list, right? What if the head is null? So if the head is null, we can just set this particular node to the head. So we can say if before head is equal to null, and then we can set this node to the head, and then we can say before head is equal to node, and then we can set the tail also to be this node. And so before tail is equal to before head. And then else, that is, in the event where the before head is not equal to null, it means that we've already started adding things to the before list. So it means that we just have to continue with the tail. So we're going to set before tail dot next is equal to node, and then we set before tail is equal to current node. So what we're doing here is we're setting the before tail dot next to the current node, and then we're setting the before tail for the next iteration to the current node. So when we want to add future nodes, we already have a base foundation that we're going to start from. And now let's deal with the case where this node's value is either greater than pivot, or equal to pivot. So if that's the case, then we just check if after head is equal to null, same thing. And then we can just set after head to be our node, and then we can just set after tail to be after head. And then what if it's not null? It means that we've already started adding elements to we've already started It means we've already started adding elements to the after list. So we can just continue from the tail and then set after tail to be equal to after tail dot next to be equal to the current node. After tail is equal to this node. So now we're almost done. We just have to make sure that this while loop is not a is not an infinite loop, so we go check for the next node. So you see we already cut off the connection of this node to its next value, right? Because we set the next to null, but then we stored a copy of it, so we have access to it, right? So that was why we copied it before before cutting access. So this was what I said I was going to explain later. So now we can just set node is equal to next, so we can go check for the next iteration. All right, so now we're done with this while loop. We have to merge the two lists together. So it doesn't make sense to merge two lists together if one list is null. If one list is null, we can just return the other lists because we don't need to merge it, right? So we say if before head is equal to null, and then we just return after head. And now we can merge both lists. So that is before tail is equal to after head. Now that's pretty much it. We just have to return before head. So that's it. That's how you solve this question. I might have some few typos in here, but I'll look at it before uploading it to GitHub. I already have the actual solution in my local repository, so I'll just upload that. So yeah, if you like this type of content, please like this video, consider subscribing to the channel, and then let me know if you want me to solve more questions from Cracking the Coding interview. Comment down below if you have something to say, and I'll see you in the next one. Bye-bye!